recording that. That's it. Alright, so I'm recording that. Let's start. I've got to clean that video up when I do this. Alright, so what we're doing is we're having a look at our bits and pieces here. So this one is the article. Can you guys hear me okay? Just give me a heads up. Assume that's okay. Yeah. Alright. So what it's doing is asking a question, not to compute this, but it's asking a question about the median and the mean. So what do you know about medians and means and skewing? Okay, medians and means and skewing have something going on with a median and a mean. So I need someone to tell me, please, what it is that causes this means and medians. What's the relationship? Okay, what's the relationship? Who would like to tell me? Who would like to tell me? Because if you're not, what I have to do is I have to do this. I have to pinch the screen and take over the sharing of the things. I can come here and look at this notability and draw a distribution for you. And in the distribution that's not skewed, the mean is equal to the median. Okay? And then the data set that pulls there's an outlier down here somewhere, a data value. It does something to the mean and the median. What does it do? It pulls the mean away. The middle score doesn't change, but this pulls it away. In the opposite direction, the long tail goes this way. The middle score still stays the middle score, but now the mean has been pulled away. Okay? So this question that we're asking to is referring to this. Okay? The mean is sensitive to outliers. The mean gets muddled around and causes the skewing of the data set. The median doesn't change, it's still the same. Okay? But the mean is the culprit. So back to your question. Okay, back to your question. Back to your question. Okay, what's going on? Look at the answers. Okay. What would you report as representative or typical value for an October snow cover for this period? And what prompted your choice? Now, Devore has implied elsewhere in other questions, if you've been doing it, that the typical or representative score, we always think of it as the mean. But why don't we think of it as a mean when they're skewing? We don't think of it as the mean when they're skewing simply because what that does is change what we think is typical. Okay? So I'm going back again. What's typical? Well, this one here, either one would be typical. I'd be fine to say either one's typical. But here, the implication is that the median is a typical score. Okay? The mean's getting fiddled with. So these are the ones that are typical. Okay? Typical. So what's happening in this question is saying what's the typical one? Okay, what's the typical one? So in a way, it's talking about this relationship between the mean and the median. Which answer best says that problem? Which answer best addresses the problem of the mean and the median? When have we ever said one of the statistics is the best measure? You've never heard that said. You've never said the optimal measure is the variance. You've never heard the optimal measure is the standard deviation. It's just never been said. So that's a ridiculous answer. Okay? It's just never been said. Okay? The median of the sample, because a potential, and Gordon, you're quite right, the potential outlier may produce a misleading mean, and we've just discussed that. The mean gets fiddled with. In other words, the mean is misled by this outlier value. Okay, the outlier value pulls the graph apart. The mean of the sample, because the mean's always the best central measure. Again, you've never been told that. No, I know Scott's never told you it's the best measure. So it's nothing to do with that. The mean of the sample, a potential outlier may produce a misleading median. Well, that's not the theory. That's not the theory. The theory is that an outlier produces a misleading mean. So you're quite right. Hold on, Gordon. Okay, it's that one. All right, how does the speed of a runner, I don't know why students struggle so much with this question. Okay, I really don't. And I think it's just because not thinking about it. Okay, so I'm going to have to think about this. How does the speed of a runner vary over the course of a marathon? And they've blocked it up into 5K blocks. Consider determining both the time to run the first 5 and the time to run the last 5, the last round of 5. So this is about running the first 5 and running the last 5. Times to run the first, times to run the last. How do they compare? Not only that, what happens if we plot them as a difference? And that's the concept that throws students awry. This is not a hard question. In fact, I'd say it's an easy question. Okay? But because we turn around and say, let's take the 2 5K times and do the difference, that throws everybody in a loop. Okay? So the 5K difference seems to cause a lot of problems. A positive value of this difference corresponds to a runner slowing down towards the end. Okay? So the difference is one time subtract another time. They're saying that a positive time implies that the second value, right, is less than the first value. The second value is the last 5Ks. Okay, so if it's 8, forget about the scale and all the rest of it, just the concept. If the second value is 8 and the first value is 10, because they ran faster in the first 5Ks, then 10 minus 8 is 2. It's positive. Okay? Which means the 8 was obtained at the end of the race, slowing down. The accompanying histogram is based on times of runners who participated in several different. So what we don't know is what's a negative value. A negative value means that the second race, the second 5Ks, the last 5Ks, was done in less time. It actually sped up. Okay? So I want you to think about that because all this is a plot of difference. Now, also, while I'm here, in the modules, what I've done is put the link for median in a histogram. So let's have a look at median in a histogram. Can you guys hear that?
Miguel tracked how much sleep he got for
Can you hear it in
50
there?
consecutive days and made a histogram of the results. Which interval contains the median sleep amount? And so they're saying, is it this interval on the histogram from 6 to 6.5, or this one, or any of these? Which of these intervals contain the median? Pause this video and see if you can figure that out.
Right, so thanks for the invitation, but no, really what he's saying is what's the middle score from a histogram? Because that's exactly what you're being asked.
All right, now let's work through this together. Let's just remind ourselves how we find the median. If I had the data points 11, 9, 7, 3, and 2, the way that we find the median is we can order it from least to greatest, or actually you can do it from greatest to least, but let's do least to greatest. So 2, 3, 7, 9, 11. And the median would be the middle number. And I have a clear middle number because I have 5 data points. If I have an even number of data points, I still would want to order them from least to greatest. So let's say that I have a 1, 1, 3, and a 7. But here, you don't have a clear middle, so the median would be the mean of the middle two numbers. So in this situation, Miguel has an even number of data points. So the median would be the mean of the 25th and 26th data point. These would be the middle two data points. So which interval here contains the 25th and the 26th data point? Well, we can start at the bottom. So we have, actually, let's just look at each interval and think about how many data points they have in it. This one has 2, this one has 9, this one has 12, and I'm just reading out how many data points there are in each of these intervals. This one has 12, this one has 11, see that there. This one has 2, and this one has 2. So if we look at just this, we have the 2 lowest. If we look at the 2 bottom intervals combined, we have the 11 lowest. If we look at the 3 bottom intervals, we have the 11 plus 12, we have the 23 lowest. So this is the 23 lowest data points. And so the 24th, 25th, 26th, the next 12 data points, starting from the bottom, starting from the lowest, are going to be in this next interval here. And we care about the 25th and the 26th, so they're definitely going to be in this interval from 7.5 hours of sleep to 8 hours of sleep.
All right. So
Miguel tracked how much sleep?
I'll just hop out of that. Okay, so you're being asked a similar thing, but your graph is a bit more complicated. So you're being asked to decide where would the middle score sit in this group. Now, it's not right to point the middle score as being at the peak here. That's not correct. I know I drew that previously, but don't let that drawing mislead you. So that means the average is somewhere away from the middle score. We know that because this is a skewed, positive, long tail to the right skewed, positive skewed distribution. So we know the mean and the median will be separated, but what's the middle score? And really you've got to go through and have a look at that. Okay? So in this case, we're not actually being asked for the middle score, but I thought I'd just bring that up for you anyway, because there's another version of this question that does exactly that, and you might get it. If you get this version, it's asking for some features. And these squares here mean that there's more than one. So what's the first thing that we can say about the features of this particular distribution? Well, it's skewed normally distributed. Oh, look, it says it's positively skewed. I think it's positively skewed. I think that's reasonable. Okay. And what else? Is it a small spread? No, I wouldn't call that spread a small spread. Negatively skewed? No, I don't think so. Normally distributed? No, it's not even somewhat normally distributed. It's fairly heavily skewed. Small sample size? I doubt it. There's thousands. If you sum all these up, they're thousands. If you do what the video suggests, you'll be doing quite a lot. So the only other thing is it's mostly positive values. There are a couple of values here where it looks like there could be 10 values where they were negative, which would be the case that the laps at the end were faster. They were faster at the end of the race than earlier. But for the rest of them, they're by and large distributed this way. So where is the negative? Where is it going to be? And if you go through and do what the video suggested, and take some rough estimates. I said 10 there. 90 is 100, 190, so 190, 280. 280 plus the one next to it, it's another 190. It's about 300, 400, isn't it? At that point, it's about 400. And then if you start adding these guys up, 160, 120s, 280, plus another, 80, 300. So you can easily see that it looks like about the 400 to 500 mark is the division. So clearly these columns here, this divider here, is representative of the middle school using that method that we just saw in the video. So it's around about this point here, plus or minus some small amount, that'll give us the median school. Okay? Now the reason for a question like this is not explicitly calculative, and some of you might think, why on earth would we do such a question? But it's your intuition. It's to give you an understanding of what the shapes are and what's misleading. It's developing your intuition. Okay? So this particular case, that's all we'll answer for that one. All right. This one's asking for the typical difference value for the previous question. I think I upgraded that, so that works. But what did I say? I'm going to go for this line here. I'm going to say that there's around about 1,000, a little bit less than 1,000. I think the 500 mark's around here. So I'm going to put around 220 or 230. It could be somewhere in that range. 230. I'm going to put 230. Please? No, it's not typing. 230. Could be 200. Could be 190. But we'll go with that for now. So that's your intuition. Okay. An article reported the following data on oxygen consumption for a sample of 10 firefighters performing a fire suppression simulation. Use your technology, whatever you'd like to do, and figure out the sample range. So I've given you an example of this here. So I put the values in here. Okay. So all I did was pick them up off the question. I just do this, control copy, come into your spreadsheet, dump them. I'll just do it over here for the sake of it. Paste, okay, and make them numbers, which they are, and we'll make them all 2s. One B, please. All right, and then I rejigged all of that, so I don't need those anymore, obviously. Rejigged all of that and put them into the columns. And then down here, I've got the max function. And then I've got the min function. And then I took the difference between the two. Okay, and that gives me the range. The max minus the min is the range. So 26.2, easy peasy. Standard deviation. So a standard deviation will allow me to compute a standard deviation of a sample. .s means the sample. Okay, and then I've just blocked in the amount, and so my standard deviation is there. Easy peasy. Okay, standard deviation 7.05. So I'll come away and put that in. Let's have a, so I'm happy with that. So any questions? You've all got access to this. Any questions? Okay. All right. And next. Oh, so this one here is going to require me to do a little bit of explanation. Now, all these questions are in Devore. I haven't dragged them out of the air. They're all in Devore. They can all be found from Devore. So you're getting your questions from Devore. It's not like I'm making them up. Okay. So I'm going to just go to, I'm just going to go to the other pattern. So I can just quickly show you something. So just forgive me while I change. And we'll go to this guy. Now, the multiplication principle. This said 20% of all phones, okay, so that's our starting point. And then it goes off and it says 30% can be repaired and 70% of those can be replaced. I think that's what it says. Well, I might have that backwards, but I'll check the question. In any case, I know that you've done this because this is a product. Okay, this is 0.2 times 0.3, and this is 0.2 times 0.7. So one of those branches is the probability that we need. So we need to read the question to make sure that we know which one it is. So if I go back to the question, 20% of all phones of a certain type are submitted to service. Of the 20%, 70% can be repaired. 70% can be repaired. Oh, and 30% can be replaced. Okay. So it looks like 20 times 30. If a company purchases 10 of these telephones, what is the probability that exactly 2 of them will end up being replaced under warranty? Okay, so we know this is a counting question, and we know that the initial setup is for so we'll come back here, I think, and we can see that it's this one. So 0.2 times 0.3 is what? 0.2 times 0.3 is what? Anybody? Someone's saying 0.6, someone said 0.06. I'm going to go with 0.06, so we're in a safe place to learn. It's always deceiving, isn't it? Okay, it's always deceiving. So this is the probability of the replacements happening. Okay? So what we're going to be doing is a binomial distribution for n equals 10. P is equal to 0.06. And then we're going to use the probability of exactly 2. And so we'll have 10 choose 2, and so on and so forth. All right? Now you can do that by hand if you want to. However, you don't need to. You can use your software, so we'll do that. But I just wanted you to see that setup, okay? So when we come to do the thing here, we've got n equals 10. Okay, n equals 10. There's our probability, which was the product of 0.2, the multiplication principle. You might have learned those as multiplication trees, okay, at school. And Q is just the 1 minus of those, okay, the complement. And that's some language that we'll have to discover a bit later on. All right, so once you've got these two values, you can come down, there's our x equals x idea, and there's our cumulative idea. And there's 2 different instructions for those. The instruction for the exact value, okay, which is the probability density, is this binomial distribution, okay. For the cumulative, okay, it's this one, and you can see the true and the false, okay. And if you check those in, it says, is it cumulative? True. Okay, so that's that one. Is it cumulative? No, it's not cumulative. So it's the probability density function. So that's how the binomial distribution function in Excel discriminates between whether it's of this form or whether it's of that form. Now that's very important, okay? the probability of a random variable is equal exactly to some number is your probability density function. The probability of your random variable being less than or equal to some number is your cumulative distribution. So we've got two different types here. So you need to be aware of which one you're going to use. Now I've included them for completeness, and then we've gone down and we've grabbed all of the data. Okay, so what's the probability of 0? Oh, hang on, just escape from that. What's the probability of 0? 1. What's the probability of 1? 34%. What's the probability of exactly 2? 9%. What's the probability of 3? 0.1%. Okay, and so on and so forth. So that's the exact language. Here it's the less than or cumulative. And you've seen plots of graphs of those. All I've done here is bring them out to decimal points because the question says round your answer to 3 decimal places. So there we are. 3dp, fantastic. 0.099. 0.09875 is the 5-digit decimal place answer to the question. 3 decimal points rounded. 0.099. Let's go and have a look. 0.099. Okay? So once you get the hang of the questions, it's certainly something that you can do. Alright? Now if I'm not a complete idiot, and I always love this moment because I've got to press that button and it all better be correct or I'm in big trouble. So I've submitted that one and gone down, and hopefully somewhere it's going to tell me how I went. 7 out of 7. So we did it correct. Okay? So we had our knowledge of mean and median. We had our knowledge of the shape and nature of a distribution. We had our knowledge of a typical score. Okay, somewhere in, oh look at that margin of 75, so the buckets are quite big there. Yeah, 100 to 50, so the buckets are 50. So 70, yeah, that's 100. So 70 is about halfway in the buckets of 50. I didn't even look at the buckets, but I should have done that. So that was okay. 190 would have been okay. 180 would have been okay, something along that. Then we had a look at the sample range, and we used calculations on Excel for standard deviation, and we were careful about that. So we got those correct. And then we had the harder one, which required you to do the multiplication principle and get the distribution correct with the binomial distribution because it's a counting problem, and referring to the binomial distribution to get your final probability. So what's the probability? It's very low, isn't it? It's 0.09. 0.09%, very low, less than 1%. Less than 1% that if you purchase 10 phones, that you're going to have to replace exactly 2 of them. Alright, so hopefully that's given you some insight. Now, are there any questions? Is there something you want me to revisit? Or you're finished, we're happy with that? Okay, so what I'm going to do is I'm recording this, so we're just on the 34, so I'm just going to press the stop button, okay, on the recorder.